Hello, Math 7 students. This is part of Unit 2 on proportions, but we do have to go back and review some 6th grade material on equivalent ratios. This is not from Open Up Resources like our other lessons are. I had to pull from Utah Middle School Math Project. This is lesson 4.1a from that resource. Now, you should have already watched the Khan Academy video, and you should be ready to answer this question. What is a ratio? Pause the video now to give yourself enough time to write down your response. Even if you are not printing the materials, you should still be taking notes. Anytime I'm writing something down, you should also be writing something down. Whenever I say pause the video, you should pause the video to do the thing that I'm asking you to do. So even if you're not printing materials, I still expect you to be following all of these directions because these are the same directions I give to the in-person students. So pause the video and answer the question, what is a ratio? Now that we're back, a ratio is a comparison between two or more quantities. Typically, we will only be comparing two quantities. Sometimes we will be looking at more than two quantities. Again, this is a review of 6th grade material, so I understand if this is familiar to you, but our assessment results show that we probably should go back and review this before diving into proportions. Taking a look at this, it says, example 1, use a tape or bar model to find ratios that are equivalent to the ratio 2 sunflowers to 6 roses. Now, that is what we should do. Notice that the work already is done for us. This first example is done so that later on, when I ask you to use a model, you'll know exactly what's expected of you. Let's review and understand the things that we are seeing. We can see that we have 2 sunflowers and 6 roses pictured. Notice that they did draw images. In the future, you can draw images, but they can be very simple. You don't have to make them quite as extravagant as these pictures are. We can see, again, 2 sunflowers, 6 roses, because that's the information that it gave us. 2 sunflowers and 6 roses. Notice the way that they are lined up. This is called a tape model because it's lined up on something like a piece of tape. We also have been instructed to write each ratio as a fraction. Let me explain what that means. In the past, when we've looked at ratios, we may have looked at them as 2 to 6, using this symbol, that colon, to show the comparison or to show that ratio. You guys are now sophisticated middle schoolers, and so we now are transitioning to fractions 2 over 6. We can still see that comparison. Something that does need to be mentioned is whenever we're looking at ratios, we need to make sure that we are understanding that these are comparisons of 2 quantities. So I do want to make sure that I am including units of measure. It's not just 2, it's 2s for sunflowers. And it's not just 6, it's 6r for roses. That's how we differentiate between a fraction and a ratio. A ratio would include those same units of measure, like s for sunflowers and r for roses. You can also see that it is written here, 2 sunflowers for 6 roses. They actually wrote it all the way out. I will not write it out. I am lazy, so I will use abbreviations like S and R. When you look at this diagram, I want you to note certain things. If a bouquet is made with 2 sunflowers and 6 roses, the 2 sunflowers are part of the bouquet, and the 6 roses are the other part of the bouquet. But all together, we have the whole entire bouquet. This is going to come up a little bit later, so please don't forget that. This is the whole amount, so we show that tape showing the whole amount and also show the pieces that make up the whole. This next step is showing us how we would simplify that ratio. Just like in that Khan Academy video, 2 to 6 is the correct ratio, but it's not quite as good as it could be. We need to simplify that. So we have 2s and 6r. What do 2 and 6 have in common? What is a factor that is part of both 2 and 6? Is there a number that I can divide out of both 2 and 6? I asked the same question 3 different ways to help you get some clues that what 2 and 6 have in common is 2. I can divide 2 by 2 and I can divide 6 by 2. So 2 divided by 2 and 6 divided by 2. Please pay attention to how I am showing my work. As we progress throughout this unit, it is going to be really important that we have concise and precise ways of showing our work, and so I'm building that strategy now. As you're taking notes, make sure that you're taking them in the same way that I am. 2 divided by 2 is 1, but not just 1, 1 sunflower. 6 divided by 2 is 3, but not just 3, 3R for 3 roses. So this is what we would do mathematically. Let's take a look at what they did with the tape diagram. Since we know that both 2 and 6 are divisible by 2, that means that we're going to make groups of 2. The sunflower already is a group of 2. We just have one, right here, one group of 2 sunflowers. These 6 roses were made into groups of 2, and so there are 1, 2, and 3 groups of 2 roses. Again, groups of 2, 1 group of sunflowers, and 3 groups of roses. And that helps us understand what we're doing when we're simplifying. If I decide to just have 1 sunflower, that's fine as long as I have just 1 sunflower and just 1 rose in each of the groups. Again, we can see that modeled here, 1 sunflower over 3 roses. And now it asks for us to create a double number line diagram. This is one of the most missed questions on the assessment, so I'm going to walk you through the steps for creating a double number line diagram. We start with not 1, but 2 number lines, hence the double number line. I do stack them one on top of the other, and it's probably a good idea to connect them like you see here so that we know that they are together, part of the same diagram and not 2 separate things. Every double number line diagram needs a label. So I'm going to label this number line sunflower and this number line rose. And now I'm actually going to create another line that's not really a line that I'm going to be using for the notes. It's not something that you are going to be drawing on your page. Instead, it's a line that is going to kind of act like a ruler for me. So if you have a ruler or the edge of a paper, like an index card or a post-it note, it would work the same way as what this line here is doing. Okay, and what I'm going to do is I'm going to make little marks on both lines, but I want them to be one on top of the other. So I'm going to make a line here for sunflower, and so right below it is going to be the line for roses. And that's why I'm using this line to make sure that they are stacked up neatly. Now the next thing I want to do is I'm going to continue making those little marks, but I want them to be about the same distance apart. So that's about how far apart this was, which means I want it to be about that same distance apart. Looks like I did a pretty good job eyeballing it. I'm going to go ahead and make my next marks. Please remember, if at any point you need to pause the video to give yourself extra time, that is what I expect you to do because I do want all of this written down. So even if that means pause it to write it down and then continue, please be good students and make sure you're writing all of this down. Again, moving that over, making sure that they're spaced apart about the same distance, and continuing on with that process. I'm going to get at least 3 or 4, maybe 5 marks on the double number line diagram. Let's do one more for good measure. Okay. I'm going to go ahead and pull this off to the side. I'll come back to it again later. Now we need, since it's a number line, we need to include numbers. So here's our sunflowers, here's our roses. You might remember that the problem was given to us with 2 sunflowers, so I'm going to go ahead and put that 2 on the sunflower one. And roses, there were 6. Again, pay attention to how that lined up. The 2 and 6 correspond with one another. And so that is why they are one right on top of the other. Now we need to figure out what we're going to do for the rest of these markings. Well, partway between 0 and 2 would be 1. Partway between 6 and 0 would be 3. Here are some ways that we can do this, and again it's going to tie into the work that we showed here. Since I'm going halfway in between, I'm going to divide by 2. So 2 divided by 2 is 1. And 6 divided by 2 is 3. That helps me understand that whatever I'm doing to one, I need to do to the other. Now I know that this probably looks a little bit different because number lines, maybe you're used to seeing them always count by ones, but this one started with 3. I didn't count by 1. But it's because 1 sunflower corresponds to 3 roses, and 2 sunflowers and 6 roses, and we would continue on. Let's do one more. Noticing that in the sunflower number line, I'm counting by ones. 1, 2. It makes sense that this next one would be 3. And in the rose number line, I'm counting by 3, 6. So the next one would be 9. That means that the ratio of 3 sunflowers to 9 roses would be the same as the ratio 2 sunflowers to 6 roses. If you have extra hash marks on your double number line, pause the video until they are all filled out. Let's check to see how you did. Again, 1 to 2, 2 to 3, 3 to 4, and 4 to 5. 3 to 6, 6 to 9, 9 to 12, and 12 to 15. Here's some other really important things to notice about this double number line. I can turn a 1 into a 3 by multiplying by 3. And the same thing will happen down here. A 3 multiplied by 3 will give me 9. You will also see we don't always have to start on this end. We can also go from 6 to 12, we would multiply by 2. And from 2 to 4, we would also multiply by 2. With that in mind, let's move on. We will return to that double number line diagram. We can write other equivalent ratios by increasing the number of flowers in each group as long as all of the groups have the same number of flowers. So if I'm going to draw 5 flowers in the sunflower group, I would need to draw 5 roses in each one of those 3 rose groups. That means I have the ratio 5 sunflowers to 15 roses written here. We can also do partials. So in this group I have half of a sunflower. That's okay as long as I have half of a rose in each one of those groups. This now means I have half of a sunflower to 3 halves of a rose, which gives me 1.5 roses. This cut off a little bit, so I'm going to go ahead and fix that. Make sure that it says 1.5 roses. Now it says list all of the ratios that you found with all of the models. So we have all of these listed, and I want to point out that all of these are equal. So where there's commas, I'm going to go ahead and change those to equal signs. 2 sunflowers to 6 roses is equal to 1 sunflower to 3 roses, which is equal to half of a sunflower to 1.5 roses, and is equal to 5 sunflowers to 15 roses. This right here I'm highlighting because it's important. This is a collection of equivalent ratios. When you have a collection of pairs of values in equivalent ratios, it is called a proportional relationship. This is what this unit is all about, is proportions or proportional relationships. So let's back up and really understand what this means. It says this is a collection of equivalent ratios, and equivalent ratios are called a proportional relationship. What does that mean? Equivalent ratios, this word here is just a fancy way of saying equal. A collector has not just one but multiple items. So a collection means, I'm going to go ahead and put many. When we have many equal ratios, remember ratio means comparison, that's when I have a proportional relationship. The next problem says find 2 other ratios that are proportional to the ratios above. We have 2 to 6, 1 to 3, half to 1.5, and 5 to 15. Can you find 2 more? Pause the video long enough for you to write down 2 new equivalent ratios. All right. You might remember from our double number line diagram, there were a couple of ratios that were not listed in the other equivalent ratios. Looking at this double number line diagram, we can see our 1 sunflower to 3 roses, 2 sunflower to 6 roses, those were listed, our 5 sunflowers to 15 roses, but these ones here were not listed. So let's go ahead and add that to our list, our collection of equivalent ratios. We have 2 sunflowers and 6 roses, and that's the same as 3 sunflowers and 9 roses. Now, I want to stop here for just a second. On all of these others, we were able to show how a 2 became another number, or how a 6 became another number. This is a little bit harder. How does a 2 change to a 3? We have to be careful. So I want us to remember that this one wasn't the simplified ratio. Let's go back to the simplified ratio of 1 sunflower and 3 roses. We changed the 2 to a 1 by dividing by 2. And the 6 divided by 2 is how we got that 3. And now we can use this simplified ratio to say, how does a 1 change? Well, we can multiply it by 3. And the same thing here, the 3 multiplied by 3 is how we got that 9. Another equivalent ratio that you may or may not have come up with, you could have come up with the 4 to 12 as listed in the double number line, but let's get a little bit creative. What else could I have done? What if I wanted to change it to 10 sunflowers? It's a big bouquet, but what would that need to look like? How does a 2 change to a 10? You would have to multiply by 5. So I would need to take the 6 and multiply it by 5 as well. 6 times 5 is 30. So this would be 30 roses. Please forgive my typo here. That shouldn't be an S, that should be an R. Sorry that I didn't catch that until now. Hopefully that didn't mess you up too much. Okay, that's it for those equivalent ratios. A few things that I would like to point out here. The reason why we started with our scale drawing and scale factor unit is because we really wanted to emphasize the point that we want to multiply. We want to look for those multiplicative relationships. So you might have answered before, oh, we can change a 2 to a 3 by adding 1, but I want you to avoid those addition relationships because that's not how we find those equivalent ratios. Stick to multiplication and division. Let's look at number 2. A vase holds 6 sunflowers and 18 roses. Is this grouping proportional to the ratio of sunflowers to roses, like we saw above? So again, let's take a look at that original ratio, 2 sunflowers and 6 roses. We want to know, because I'm asking the question, so I'm putting an equal sign with the question mark. Is this equal to 6 sunflowers and 18 roses? So I might ask myself that question. How does a 2 change to a 6? We would multiply by 3. So if I take this 6 and I multiply it by 3, do I get 18? We do. So this would be proportional to what we already saw, what the existing ratio is. And our final question. Another vase holds 9 sunflowers and 21 roses. Is this grouping proportional to the ratio of sunflowers to roses as seen above? And remember, when I'm asking, is it proportional, I'm asking, are they equal ratios? So we're going to start with that original ratio, 2 sunflowers to 6 ratios. And I'm asking that question, is this the same as 9 sunflowers and 21 roses? Asking that question. Again, this one is challenging. Do you know how to turn a 2 into a 9 through multiplication? Probably not very easily. You might, but it's not quite as simple. So let's go back to our simplified version of that ratio again. Let's simplify this to 1 sunflower and 3 roses. We may not know how a 2 multiplies to become a 9, but it's a lot easier to find out how a 1 multiplies to become a 9. 1 times 9 is 9. So let's do the same thing down here. 3 times 9 is 27. But that's not what this ratio is. It says 21. So if I multiply by 9, I should get 27 roses, and I'm not. I'm getting 21 roses. So is this proportional? No, it is not proportional because it is not an equal ratio. So I answered the question, is it proportional? Instead of that question mark, let's go ahead and cross that out. It is not equal, so it is not proportional. That's it for today's lesson. We will have a second video for the rest of the lesson, so come back tomorrow for the next video. That's it for today. Have a good one. We'll see you next time.